Hey guys, today we're going to learn about vertical and adjacent angles. By the end of this lesson, you will be able to write and solve simple equations for an unknown angle using vertical and adjacent angles. Go ahead and get out your notes and be ready to learn. So before we get started, let's look at this diagram and talk about what vertical angles are and what adjacent angles are. Vertical angles are angles that are across from each other. So in this picture, 1 and 3 are across from each other. So there I've got those identified in yellow for you. We've also got angle 4 and angle 2 are also across from each other. So this diagram has multiple sets of vertical angles. Those are kind of outlined in red for you. Then we have adjacent angles. Those are angles that are next to each other. In this diagram, we've got angle 1 and angle 2 are next to each other, 2 and 3, 3, 4, 4, 1. So this one has a lot of examples of adjacent angles, but I'll just outline that 1 and 2 are adjacent or next to each other. So this information is going to be pretty important for today's lesson, knowing that vertical angles are across from each other and adjacent angles are next to each other. Let's go ahead and look at our notes. So angles are formed when two lines intersect or cross. In our picture, we have lines X and Y that are straight lines that intersect. Our lines are labeled, this is line X, this is line Y. It says to use a protractor to measure each of the four angles that were formed and complete the table. So I'm going to do this, but you're not going to be able to see the protractor that I use to actually measure. So I'm going to explain. Here is a picture of a protractor. Remember, we looked at this in our last lesson. I will line up my angle with this point right here. I'll line up the vertex of the corner right there. And then I'll line up one of the straight lines with the edge. So I'll have the vertex here and an edge here. Then the other ray is going to go somewhere across one of these angled degrees. And then, depending on if I'm starting at the left or the right, I'm going to measure using the top or the bottom angle. So when I use my protractor, I get the angle A is 50 degrees. Now, without even using a protractor, you should be able to figure out what angle B is. Go ahead and pause the video and think about what we learned in our last lesson and see if you can figure out the measure of angle B. So what we learned in our last lesson was complementary and supplementary angles, and supplementary angles make a straight line and have a sum of 180. So angle A and angle B here make a straight line. That means if angle A is 50 degrees, the remaining would be 130 degrees. We can actually use this information to figure out C and D as well, because if I turn my paper a little bit, I see that angle B and angle C also make a straight line. So if B is 130, the other part of that straight line is 50. And then again, if you look down at the bottom, my straight line here, angle D and angle C are on that straight line and have a sum of 180. Our next question asks, what do we notice about the angle measures? I want you to pause the video and see if there's anything that you notice. So I kind of already talked about some being supplementary, A and B, or C and D. But also I noticed that A is 50 degrees and C is 50 degrees. That makes those angles congruent. And congruent just means they're the same. This also means that angle B that's 130 and angle D that is 130 are also congruent. Our next question says, what do you notice about the sum of all four angles above? Go ahead and pause the video and find the sum of those angles. When I add those angles together, I get 360 degrees. I also kind of already knew this because if these two angles are supplementary and are 180, and these angles are also supplementary and 180, I know that the sum of two 180 degrees is 360 degrees. Next, we're going to talk about our two types of special angles that are formed when two lines intersect. We can use our picture above and the table to define and describe these types of angle pairs. Vertical angles are pairs of opposite angles formed by intersecting lines. Vertical angles are also angles that are across from each other. So in our diagram, I see that angle A is across from angle C. So there's one example of vertical angles. Also in that diagram, B is across from D. So those are also vertical angles. Looking over here at the table, I labeled that A was 50, C is 50. And since those are vertical angles, that's interesting that they are the same angle, but same measure. But also B and D, which are across from each other, and we have now determined are vertical, are also the same. So it's important to know that any vertical angles are congruent, which you can remember means they have the same measure. Next, we're going to look at adjacent angles. Adjacent angles are two angles that share a common side and a common vertex. So a side is just one of these lines, and the vertex is the corner. So in this case, all of them share the same corner. They all meet right here in the middle, but not all of them share a same side. So if we look for some examples here, I see that angle A and B share this line. So angle A and angle B are adjacent angles. I also see here that B and C share this line and that vertex, so B and C are adjacent angles. There are some other angles in this diagram that are vertical or adjacent as well, but let's focus on these. Looking over here in our table, I have angle A and B here, and I already determined that the sum of those was 180. And then I have B and C, which I see as 130 and 50, and if I were to add those together, I'd also get 180. So the important thing about adjacent angles are that they are supplementary, or that they're also going to equal 180. So now we're going to use what I know about intersecting lines to label missing angles in the pictures below. So in our first example, I have this angle labeled as 148, and this is an unknown angle. Those angles do not share a common side, but they are opposite of each other, so these are vertical angles. Since they're vertical angles, I know that vertical angles are congruent, or the same measure. So that means that angle X is also going to be 140 degrees. And as I said, these are vertical angles. Looking at our next problem here, I have angle 35 here and angle X here. Well, these angles do share this corner, and they share this line. This makes them adjacent angles, and they are supplementary. That angle measure is 35 degrees. The remaining amount in 180 is 145. So in our next examples, we're going to be looking at some angles that may not be supplementary or complementary. And we can know this because this line right here, this little gray line, tells us that this whole angle is 117. And I know that this part of the angle is 94, but I'm looking for this part of the angle, which is X. So I'm going to use these pieces of information to set up an equation. But before we get there, I want you to tell me, are these adjacent or vertical angles? These angles are adjacent. They are next to each other. They share this corner and this line. So I'm going to go ahead and set up an equation to solve for this unknown angle. A lot like setting up our equations in our last lesson. Instead here of one of them being 90 or them being 180 for complementary and supplementary, I know that the sum of these angles is going to be this whole piece of 117. So I have this 94 degree angle, and this X angle is going to equal 117. Now I can solve. Once I solve, I get that the measure or value of angle X is 23 degrees, and then our two angle measures in this diagram are 94 and 23. Looking at number 4, again, I want you to tell me, are those vertical or adjacent angles? They are adjacent. They share this vertex here and this line here. Looking at these angles, again, they're not complementary or supplementary. I have this line telling me that the whole value of this is 141 degrees. This one's a little different too, because I have this angle is 2x and this angle is x. So I still know that the sum of these angles is going to be 141. And I'm going to have to use a little bit more of what I know to be able to solve this equation. I know going back several units that 2x and x are like terms, so I can combine those and have 3x equals 141. Now it's a little different here because we're not adding anymore. We've got 3 times x, and so I've got to do the inverse of multiplication and divide by 3 on both sides to find out that the value of x. So the value of x here is 47, but we actually have one more step to do. So that tells me that this angle is 47, since that angle is just x. But my other angle is labeled as 2x, so I still haven't found out what that angle measures yet. I know that it's 2 times the value of x, or 2 times 47. This means that my angle measures in this diagram are 47 and 94. Let's look at number 5. Again, I want you to pause the video and let me know, are they vertical or adjacent angles? These angles are vertical angles. They are across from each other, or opposite. So I've got this 20-degree angle and this 3x angle. I know that vertical angles are congruent. So when I write this equation, I can set those angles as being equal to each other. 3x equals 20. Now I can solve for x to find the value of x. When I divide by 3, I get 6.6 repeating. But again, this isn't telling me that this angle is 6.6 repeating because this angle is 3 times x. So now I've got to multiply 3 times 6.6 repeating. I also know that these angles are congruent, which means they're going to be the same. So once I do 3 times 6.6 repeating, I should get 20, and I do. So I know that these angle measures are 20 degrees and 20 degrees. Angle relationships allow us to determine any unknown angle measures. All angles around a point or a vertex will always have a sum of 360. So we saw that in our diagram on the front where we had 2 intersecting lines and all of the angles around that added up to be 180 or 360. So now we have these diagrams that look just a little bit more complicated because we do have quite a few angles around that point. But we know that all of these angles added together should equal 360, or will equal 360. So we're going to set up and solve some equations to find the missing angle measures. And we'll use what we know about complementary, supplementary, vertical, and adjacent angles. So first it looks like we're going to solve for angle K. So here's angle K, and I'm going to look around at the angles near angle K to see what I can figure out. Well, here I see some straight lines. I've got this line that intersects and this line that intersects, and they are straight lines. So at this line, if I look, I have K, 40, and 60 that make up that straight line. Those colored for you, 60 being blue, 40 being red, and K being yellow. So those 3 angles together make 180. To make my equation here, I've got 60 plus 40 plus K equals 180. Then I can solve 60 plus 40 is 100, subtract that from 180, and I get that the measure of angle K is 80 degrees. Now, there are a couple of ways that I can find angle M. I've got some different pieces of information here. I know that right here I again have a straight line, so K and M are going to be 180. But you want to be cautious in doing that because if you had made some kind of mistake with angle K, then angle M would also be wrong. So it's really best to use angles that you already know. In looking at this diagram, the only other angles that I know for sure are 60 and 40. But if I look at those, that can help me here. If I look at the whole 60 and 40, those angles are across from or vertical to angle M. And vertical angles are congruent. So I know that the sum of 60 and 40 needs to equal M. And we already said that 60 and 40 is 100. So I know that the measure of angle M is 100 degrees. This diagram, again, we've got several angles here. Looking at this angle, though, I want to point out this box again. Remember that this box tells us that that is 90 degrees. The first angle we're looking for here is the measure of angle G. So here is angle G. I see that angle G and angle J make a straight line, but if I don't know either one of those, I can't really figure out the other one. So looking at this whole diagram, I do know that this angle is 32 degrees, and this angle is 90 degrees. So if I look at the sum of these 3 angles again, I've got a straight line. that's really one thing I look for a lot, is finding a straight line, since we know that those are 180. So here, if I'm going to take 32 and 90 and angle G, those need to equal 180. Now I can solve for G. Once I solve this equation, I get that the measure of angle G is 58 degrees. Now we know that we already said that G and J are a straight line, so I can take 180 and take away angle G of 58 to be left with J, but like I said, you may have made a mistake, so you've got to be careful. So looking at this, I have angle J here, and I see that these angles across from it together make vertical angles. So I know that if I find the sum of 32 and 90, that is going to give me the measure of angle J. This gives me the measure of angle J being 122 degrees. Let's look at number 8. I've got two angles outlined here for me, 112 and 29 here, and I'm just looking for angle Z here. Again, I like to look for a straight line, and I see right there against that line all three angles are going to be combined to make that straight line. So my equation here, I can take those three angles, 29 plus Z plus 112, and I know that that straight line is 180. Once I solve this equation and take 29 and 112 away from 80, I get that the measure of angle Z is 39 degrees. Go ahead and summarize on your notes today's lesson in about 2 or 3 sentences. Remember, in our summaries, we should be using correct vocabulary that we have learned and complete sentences. If you've made it to the end of the video, let me know, what is your favorite thing to learn about? It can be a school subject or something outside of school. In today's lesson, we learned about vertical and adjacent angles. By the end of this lesson, you should now be able to write and solve simple equations for an unknown angle using vertical and adjacent angles. Let me know if you have any questions. Bye, guys!